Hi everyone, and welcome to our video on the topic of probability. Again, as with many things in this chapter that we've been studying, you may have seen it before. You may have seen it on Alex, but we're going to go ahead and plunge through with our lesson. So let's take a look at the definition. The definition of probability is this. Probability is the likelihood. I like that word. It's the likelihood of something happening or being the case. In mathematics, probability is measured by the ratio, that's a fraction, of favorable outcomes to possible outcomes. So it's a fraction where your favorable outcomes are the numerator and the total possible outcomes are the denominator. And that's really all you need to know in order to do these examples. So let's take a look. Example 1. It says, a bag has 2 black marbles, 1 white marble, and 3 gray marbles. A marble is chosen from the bag at random. So you reach your hand in the bag, you're not looking inside, you're just picking a marble randomly. The question is, what is the probability or the likelihood that the marble you pick is black? So this is how easy this is. We're going to write probability equals, and I want you to set up your fraction. Okay, so our favorable outcomes. Well, to me, since we're looking for the probability of black, this is what's favorable. We want to pick black. So we have to go up in our sentence here and find how many black marbles there are. Well, there are 2. So we have 2 favorable outcomes. So I'm going to make my numerator 2. Now, the denominator is the total possible outcomes. Like when you reach into that bag, how many marbles are you choosing from in total? So for that, I'm going to actually add 2 black ones, 1 white, and 3 gray. So if you add 2 plus 1, that's 3, plus 3, you're looking at 6. So the probability that you're going to choose a black marble at random is 2 out of 6. Now, we should reduce that. In probability, you do want to reduce. So 2 6 reduces to the fraction 1/3. And that, as a decimal, is 0.3 repeating. And that, as a percent, if we multiply by 100 or move the decimal 2 spots to the right, we would get 33.3%. Because obviously this is 0.3333 ... So you go 2 to the right and you're sitting at 33.3%. So it just depends. If it's a multiple choice question, you just have to kind of look at how they've written the result. If it's a fraction, if it's a percent, if it's a decimal, just be ready for anything there. Okay, let's look at example 2. 10 tickets are numbered 1 through 10 and placed in a box. 1 ticket is drawn at random from the box. Find each probability. So we have lots of different things going on here. So we're just going to start in with letter A. What is the probability of drawing a 4? Okay, well, let me draw these 10 tickets. So I've got 10 tickets. I'm going to draw them down vertically here so I have space. So say these are my tickets. 1, 2, and don't feel like you have to draw this, but for some people the visual helps. 5, wait, 1, 2, 3, 4, 5, 6. There's 6 there, and then I'll draw 4 more. We'll put them over here. 7, the 8th ticket, the 9th ticket, and the 10th ticket. So you have these 10 tickets, and they're numbered 1 through 10. So I'm going to call, it's my red pen. So this is ticket number 1, ticket number 2, 3, 4, 5, 6, 7, 8, 9, and 10. So there are my 10 numbered tickets. Now, what is the probability that you're going to draw from the box? Remember, these are all in a box, that you're going to pick the number 4. Well, let's do P for probability equals. Let's create our fraction. Okay, let's list our total outcomes on the bottom. The total outcomes are these 10 tickets. So I'm going to make my denominator 10. And there's only one 4. So you basically have a 1 out of 10 chance of drawing the 4 out of the box. It's that simple. Look at letter B. What is the probability of drawing the 8? Same thing. There's only one 8. So you have a 1 out of 10 chance of drawing the 8. Letter C. What is the probability of drawing a 6 or a 7? Now, this is the first time this has come up, the word or. So let's just do a side note. In probability, when you see the word or, you are going to add two probabilities together. So or goes with addition. While we're here, when you see the word and in a probability setting, and means you're going to multiply probabilities together. We'll see that a little bit later. But for right now, it's an or. So or means add. So keep that in mind. So when we go to do a 6 or a 7, here's what we have. Well, the probability of drawing a 6 is there's only one 6, so a 1 out of 10, plus the chances of drawing a 7 are also 1 out of 10. Well, when you add 1/10 to 1/10, we already have a common denominator, so we add the numerators, 2/10. So you have a 2 out of 10 chance of selecting a 6 or a 7, which you would have known anyway because the 6 is 1, the 7 is 1, so together that makes a 2 out of 10 chance of doing this or that, one or the other. If you reduce that fraction, you get 1/5. So I'm keeping everything in fractions here. Of course, we could divide them, get a decimal, multiply by 100, and get a percent. All right, let's look at D. What is the probability of drawing a number that's less than 5? Okay, well, how many numbers, what's favorable? How many numbers are less than 5? So here's ticket number 5. Less than that, we have 1, 2, 3, 4. We have 4 tickets with numbers less than 5, so we have a 4 out of 10 shot of drawing such a number. If we reduce 4/10, we get 2/5. And we're cruising. Letter E. What is the probability of drawing a number greater than 8? Greater than 8, not equal to, greater. So here's my 8. Here's my 8. We only have numbers 9 and 10. So we have a 2 out of 10 chance of drawing a number greater than 8. That would be 9 or 10. Again, that reduces to 1/5. Okay, letter F. What is the probability of drawing a number that's divisible by 4? Okay, well, let me set this up. I know my denominator is 10. Now I have to just figure out my favorable outcomes. How many of the numbers are divisible by 4? All right, well, 1 is not divisible by 4. 2 is not divisible by 4. 3 is not. 4 is, because 4 divided by 4 is 1. 5 divided by 4, nope. 6 divided by 4, nope. 7 divided by 4, nope. 8 divided by 4, yes, that's 2. 9, nope. 10, nope. So there are only 2 numbers in this set of tickets that are divisible by 4. So 2 out of 10. That's another 1/5. Letter G. What is the probability of drawing a number between 2 and 7? Okay, between 2 and 7, that means not including. So we have the 3, the 4, the 5, and the 6. So we've got 4 numbers out of 10. That reduces to 2/5. Isn't this getting easier? Okay, that was G. H. What is the probability of drawing a number between 3 and 9? Okay, between 3 and 9, not including. So between 3 and 9, we would have 4, 5, 6, 7, and 8. So that's 1, 2, 3, 4, 5 out of 10. 5 numbers out of the total 10 are between 3 and 9, and so that's 1/2. Okay, so that completes the first side. Pretty simple probabilities. Let's turn it over. We've got 2 to go on the back, and we'll call it a day. Example 3. A box is filled with 4 yellow cards, 3 brown cards, and 8 blue cards. A card is chosen at random from the box. What is the probability that it is a yellow or a blue card? Let me highlight the or. Remember, or means add. So we're going to add 2 probabilities together. First, we'll do the probability of the yellow, and we'll add it to the probability that we choose blue. Okay, so favorable over total. So yellow is favorable. So let's figure out how many yellow we have. 4 yellow. 4 yellow. So 4 will be the numerator. Out of. How many total? Well, 4 plus 3 is 7, plus 8 is 15 total cards. Now we're going to add that to the likelihood of the blue card. So favorable is however many blue we have, and we have 8 blue. So 8 out of 15. And so we add those together. 4 plus 8 is 12. Carry along the common denominator. 12 out of 15. And so that reduces to, they're both divisible by 3. So we'll call this 4/5. If you divide 4 by 5, you're going to get 0.8. And if you multiply by 100, you're going to say 80% chance. So we have an 80% chance of drawing blue or yellow out of this box. Okay, last example, example 4. A 7th grade math class has 2 girls and 6 boys. And an 8th grade math class has 5 girls and 3 boys. So what I'm going to do first, I'm just going to stop right there, and I'm going to draw this out. So my 7th grade class and my 8th grade class, let's see what we have. So the 7th grade class has 2 girls, so we're going to do a girl and a girl, and 6 boys. So 1, 2, 3, 4, 5, 6. These are all boys. We'll do B for boy. Okay, the 8th grade class. 5 girls. So 1, 2, 3, 4, and 5. These are my G's. These are my girls. Girl, 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 girl. And 3 boys. So 1, 2, 3. Boy, boy, boy. Now you don't have to draw this out. It just seems to help me sometimes when we have lots going on here. Let's keep reading. The teacher randomly selects a 7th grader and an 8th grader. And means multiply. So I'm already going to do this. I'm setting up my multiplication. The teacher randomly selects a 7th grader and an 8th grader from the class for a competition. Here we go. What is the probability that the student she selects are both girls? So we're going to take the probability of choosing a girl from this class and multiply it by the probability of choosing a girl from this class. So we have to do likely or favorable over total. Okay, so the likelihood of choosing a girl from the 7th grade is 2 out of 1, 2, 3, 4, 5, 6, 7, 8. The likelihood of choosing a girl from 8th grade is 1, 2, 3, 4, 5 out of 1, 2, 3, 4, 5, 6, 7, 8. They both have 8 total students. Now, when we multiply fractions, we truly just multiply numerator to numerator, denominator to denominator. So 2 times 5, 10. 8 times 8, 64. This will reduce. They're both divisible by 2. So this will reduce to 5 out of 32. I'm not sure what that is as a decimal, so let me grab my TI. 5 divided by 32 is 0.15625. 0.15625. And that, as a percent, 1-2, would be 15.625% chance. Okay? So you see the and, you've seen the or, you've seen simple probabilities, definition of probability. So we'll do some practice. Thank you for watching.